Hello everybody. So we are looking at some problem solving with binomial expansion. So let's start with this first example. In the expansion of x plus p to the eighth, the sixth term is 1512 x to the fifth, and we want to find the value of p. So just like in that last video, we are always going to start with the general term. So by now, hopefully you're getting used to seeing that format. So it's always NCR. The reason I have an 8 here is because we have an exponent of 8. So 8CR, and then it's x to the n minus r, and we know again n is 8, and then p to the r, okay? And they're telling us about a specific term. They're telling us the sixth term is 1512 x to the fifth. So just like that last video, here's the only place that I have an x, which means that this exponent has to be 5. So that gives me a lot of information. So now I can fill in. This is going to be 8c, let's leave this blank for a second, x to the fifth. If we know that 8 minus something is 5, we know that that something has to be 3. So p to the third and 3. So real quick, just to make sure you understand where I'm getting that 3 from, you can think about it two ways. Either we know that these exponents have to add up to 8, and 5 plus 3 is 8. Or if you needed to, you could always say, we know 8 minus r has to equal 5, and then solve this. So that means that negative r equals negative 3, or r equals 3, and we can plug that straight in. Okay, so let's go ahead and simplify this term. If we do 8c3, 8c3 comes out to 56. To find that, you can use your calculator. You can just type it in, or you could use the formula or Pascal's. So 56, x to the fifth, p to the third. Okay, and now they're telling us the sixth term equals 1512 x to the fifth. So now I can take the term that we just created and set it equal to the 1512 x to the fifth. Okay, and then this is how we solve for p. So first, divide both sides by x to the fifth, and that goes away. So 56p cubed equals 1512. Divide by 56, and we get p cubed equals 27. And then if you cube root that on both, we get that p equals 3. And that's our final answer. Okay, let's do another problem like that. Okay, in this one, in the expansion of x minus k to the sixth, the coefficient of the term in x to the fourth is 375. When it's written that way, another way you could write this is saying that there's a term that equals 375x to the fourth, okay? And then it's just like the one we just did. And we want to find the possible values of k. So again, we're going to start with writing our general form. So this time we have 6cr, and then x to the 6 minus r times negative k. Make sure you have the negative k to the r. Okay? All right. From here, we are given that x needs to be to the power of 4. And if we know the exponents have to add up to 6, that means that the r would have to be 2. So if we fill this in, we've got 6c2 x to the fourth, negative k squared. Okay. If we evaluate 6c2, that's 15. So 15 x to the fourth. If we have negative k times negative k, that's going to be positive k squared. And again, now we can take this term and set it equal to what they told us that that term should equal. So we have 15x to the fourth k squared equals 375k to the fourth. we can divide by the, x to the fourth, not k to the fourth. So 15k squared equals 375. Divide by 15. K squared equals 25. And then square root. And k equals plus or minus 5. Okay? And that's why it said possible values of k, is because we're getting positive and negative, so we actually get two answers. Okay, quick correction I just realized as well is up here, this was a mistype here. This isn't the sixth term, this should be the fourth term. I had made a mistake there. So fourth term, none of the math changed, that was just not the correct term, so be careful there. All right, so today we learned how to solve for a variable given a term in the binomial expansion. So if you have any questions, feel free to message me. Again, I know you guys are going on a trip, so just come see me tomorrow if you need any help or need some clarification. I'll post the key to the assignment later so that you can make sure you're doing things correctly. Have a great day.